Morning, good afternoon, everyone, from whatever time you're joining us. I'm glad to see you all again. Welcome back to day 2 of our webinar series on Copernicus for land degradation and agriculture and food security. My name is Grace Akot from RCMRD Regional Center for Mapping of Resources for Development. And I'll be guiding you through today's session together with my colleague Sonia from European Space. Before we begin today, we'd like to apologize for the 1 hour lateness that we started with today. Thank you for your patience and for your understanding, and thank you for joining us. As you might recall, this webinar is under the framework of GMS and Africa from RCMRD. And yesterday, we started with the foundation of Copernicus, an overview of the Copernicus program, its services and the critical role of Earth observation in climate monitoring. That was our last speaker. And today we'll be exploring practical sessions on real-world use of Copernicus in tackling land degradation and food security. We are honored to have 2 speakers from VITO. I hope I'm pronouncing that well, who will show us Copernicus data and how it's being used in the mentioned applications. We can have a Q&A session after the presentations, but feel free to write your questions in the chat box or in the Q&A segment. Once again, we are grateful for your participation and we look forward to another inspiring and impactful session. Over to you, Sonia, to introduce the speakers.
Thank you, Grace. It's a pleasure to be here for the second day of the webinar. So as Grace said, yesterday you heard a presentation on Copernicus and the services from Stefan Urovic, the supervisor at the EU Space Support Office. And today we have with us Ruben van den Kerkhove and Koen de Vos from VITO Remote Sensing in Belgium for a more in-depth presentation on use cases and success stories on Copernicus for land degradation, agriculture, and food security. So thank you again for joining us, and I leave the floor to Ruben for his presentation.
Hello, good morning from rainy Belgium. First of all, thank you for the invitation to present today at this webinar. I will indeed go a bit deeper in some of the activities that we are doing at VITO related to land cover monitoring and land degradation monitoring. So let me first share my presentation. I think you should see it. Good. So indeed, I'm Ruben van den Kerkhove. I'm a project manager at VITO Remote Sensing. I mainly work on applications related to vegetation and land cover monitoring. And like I said, today I'm going to show you some of the projects and services that we're working on related to global land cover mapping and monitoring, and also land degradation monitoring. Using Copernicus Sentinel data. So to start with, I just want to show you this image, which is actually an image of a forest fire over Siberia. It's already quite old. It's from 2018, but it's still very, very relevant. Yeah, as we all know, our Earth is changing every day. And we can use Copernicus data really to monitor the changes, and that's really important. Yeah, we need to constantly have an eye on how our Earth is changing, and the Copernicus data, the Copernicus space program, the Copernicus service allow us to monitor this. This is an RGB composite, so this is actually how our human eye would also see it from space, from above. And this is actually a false color composite using also a shortwave infrared band visualized here in the red band. And actually, it shows that by using the right combination of bands of these satellites, we can actually somehow also see through the clouds and also see a bit the temperature of the fires. So these satellites really offer a lot of potential to study what's ongoing on the Earth's surface, and this is actually what I'm going to talk about today. So I want to first highlight a bit more the power of the Sentinel-1 and Sentinel-2 data, which are, I believe, two Copernicus satellites, which were already introduced to you yesterday during the first session. Then second, I will move onwards with providing some more details on the global land cover mapping initiatives that we are carrying out at Vito. We have some existing services and projects, but there are also some upcoming services and projects. And yeah, I will also detail a bit more how this can be used and for land degradation monitoring. So I think this slide you might have seen today, or at least yeah, for those that were not there, I can just detail it once more. So the Copernicus space component actually yeah, consists of several satellites, so-called sentinels. Sentinel-1, Sentinel-2, Sentinel-3, 5P, 4, 5, 6. So different sentinels, and each satellite has actually different capabilities. Today, I'm mainly going to talk about Sentinel-1 and Sentinel-2 data. So Sentinel-1 is a radar satellite with a spatial resolution of about 20 meters, a revisit time of about six days. And actually, what's really interesting is that this radar satellites, they can actually penetrate through cloud cover. Yeah, they always observe, can always observe what's at the Earth's surface. However, they are radar satellites, so the signal is the backscatter that's returned to the satellite is not always that easy to interpret. That's a bit different with Sentinel-2, which is an optical satellite. Yeah, which you might be familiar with it. It comes with 13 bands, a spatial resolution of 10 to 20 meters, depending on the band, and a revisit frequency of about 5 days. So together, Sentinel-1 and Sentinel-2 can create this kind of images. On the left, you see a rotating globe with a Sentinel-1 composite of different backscatters. And on the right, you see actually a cloud-free composite of Sentinel-2, which is actually, yeah, Sentinel-2, in contrast to Sentinel-1, is actually affected by cloud cover. So if there's a cloud, we cannot see the Earth's surface. So if you're going to use Sentinel-2 data, first thing you need to do is, and you want to observe what's at the Earth's surface, is, yeah, you need to first discard the clouds, also the cloud shadows, and then you can create this kind of beautiful composites like you see on the right. So this is the data we're using mainly in our work at Vito. Just to, yeah, before I showed you the global image, this is a zoom of such a Sentinel-2 image over the city of Antwerp, which is nearby the Vito headquarters. And actually, what you see here is a false color composite. So the colors are a bit different than what we see with our human eyes. Vegetation, active vegetation, is actually colored here in red, and that's because the near-infrared band is assigned as a red color. So, but yeah, you see immediately that the spatial resolution of Sentinel-2, which is 10 meters, allows us to really map the rivers, also the city center, the urban green, also the croplands surrounding the city. So yeah, it's really a great detail. And what's really important is that all this Copernicus data is, of course, also free and openly available. So yeah, that's a major data set which can be used for downstream applications. This is then a Sentinel-1 composite of the same city of Antwerp. It looks a bit different. Still, you see, we can also differentiate different land cover types. You see that the river, which is here in blue, can be easily differentiated. That's because water absorbs radar signal. So when it's returned to the satellite, actually there's a low backscatter. In contrast, urban surfaces, like you see here, the city center, they have a very high backscatter, so it shows up as white or as yellow. And then we have the more natural vegetation, like the forest. These have some in-between backscatter values. So yeah, the advantages of Sentinel-1 and Sentinel-2 for land cover mapping is really that it offers a high spatial resolution. It comes with a rich spectral information. So Sentinel-2 has a lot of bands. And thanks to Sentinel-1, we can also observe through the clouds, and we also have a sensitivity to surface structure. There's a frequent revisit time of 5 to 6 days, and it's free and open data. So this kind of data really allows us to create products, land cover products, with an improved accuracy and also with a more detailed and comprehensive classification scheme. And thanks to the, let's say, the temporal resolution of 5-6 days, we can really now also move towards more continuous monitoring and near real-time change detection. So this as an introduction. Now I will go over some of the existing global land cover initiatives that we carry out here at Vito. So first of all, I want to show you this image. Some of you might be familiar with it. It's actually the Copernicus global land cover map at 100-meter resolution. It has been processed as part of the Copernicus Land Monitoring Service, and it's available for the years 2015, 16, 17, 18, and 19. So it's an annual product, and it comes with 23 classes. So it stopped in 2019, but so we have a time series from 2015 to 2019, and there's also some you can also use it for change detection. So 23 classes, and at the time when it was released, what really innovative is that the spatial resolution for 100-meter resolution. 100-meter resolution, and secondly is that beside the discrete classification, which is what you see here, so just every pixel is here assigned to a certain land cover class. You see the land cover classes on the left. It also provides cover fraction layers. So per pixel, the Copernicus global land cover also provides 10 cover fraction layers. And a cover fraction is actually, for instance, for every 100-meter pixel, it says, what is the percentage of tree cover in this pixel? What's the percentage of cropland? What's the percentage of grassland? What's the percentage of shrubland? And by combining these different cover fraction layers, you can then, for instance, create this kind of visualizations, like what you see here in this image. Compared to, for instance, the discrete classification, this cover fraction layers, they provide much more detail. It allows really to better study the smooth transitions between the different land cover types. So if you can combine this discrete classification with these cover fraction layers, you can actually create and customize products, for instance, for forest monitoring or biodiversity or for crop monitoring. And this is also one of the major added values of this product. What's also important is that this product, it's an operational product. It was provided by the Copernicus Global Land Service, so it comes with a certain quality standard. So the product has an overall accuracy of about 80%. And if you want to access it, please visit the Land Copernicus EU website. It's also on Google Earth Engine. If you're familiar with Google Earth Engine, you can download it from Zenodo. And of course, there's always product documentation, such as a product user manual, an algorithm description, and also a validation report. So this was actually the first land cover product that was created by a consortium led by Vito. Some of you might also be familiar with this product. This is the European Space Agency World Cover product. It's for the year 2020. It comes at a spatial resolution of 10 meters. So the maps before were at 100-meter resolution. This one comes at 10-meter resolution, and it's based on Sentinel-1 and Sentinel-2 data. Actually, it was the first global land cover map that used both Sentinel-1 and Sentinel-2 data. It doesn't have 23 classes like we had in this Copernicus global land cover map, but however, it provides 10 classes, which you see here on the left. So it was released for the year 2020, and yeah, ESA was rather happy with the results, so they also asked us to provide an update for the year 2021 with an improved accuracies, which we actually did. But this was a part of an European Space Agency project, so not an operational Copernicus service. It used to have Copernicus data, Copernicus Sentinel-1 and Sentinel-2 data, but it was more a kind of demonstrative project. So there are no further updates of world cover planned for the year 2023-4. However, yeah, I will come back to that in a second. The same algorithm will be also, or the same type of product will be also embedded in an upcoming new Copernicus service. So just to show you a little bit how this product looked like, this is again the city of Antwerp, the Sentinel-2 composite. This is, for instance, then the 100-meter global land cover map that I showed you earlier. You see that yeah, we can depict the urban areas, which are here in red. We also see the rivers, the river and also the harbor in blue. The cropland areas, they are visible in pink, and also the more natural forest classes, we have them here in green tones. So we see the major areas, but we don't really see the fine spatial detail. This is, however, different when we move towards the world cover product, like what we see here. Yeah, what immediately is striking that at 10-meter resolution, it's now also possible to see the major roads. We can see the fine green elements in the city centers. We can see parks. We can see larger trees. We can also better delineate the crop fields. And also the urban settlements. So really this improved spatial resolution of 10-meter really makes a big difference in what's possible to observe. This is another example of the Sinissalum Delta in Senegal. So you see we all have also mangrove as a class. You see also the small settlements, the croplands in between these mangrove areas, as well as the different villages. Another example of San Francisco in the United States of America. We even see the Golden Gate Bridge on the and also the island of Alcatraz, the Golden Gate Park. So we see the green elements in the city. So yeah, 10-meter resolution really boosts what's visible in these land cover maps. However, yeah, like I said, we have 10 land cover classes. Some of the limitations that we have with these 10 classes that we don't differentiate, for instance, between what's natural grassland and what's more pastures. Yeah, so we all have it as grasslands. So that's one limitation that was often put forward by users. Secondly, also agroforestry. We like what you see here on in the center. We map it as trees. So we don't make a differentiation between natural tree cover and, let's say, managed tree cover or plantations. And also things like vineyards, what we see here on the right, they mostly show up as shrubs. So the legend, what we're using, comes with certain limitation. So yeah, it's good that you're aware of that. The second limitation in the world cover is also that yeah, if you're going to compare the 2020 and 2021 product, is actually that you cannot really use it for change detection, because in 2021 actually we used a different algorithm. So it makes that when you going to compare the two, 2021 and 2020, actually the maps, it makes that you have both real land cover changes, but also improvements due to the algorithm. And this is actually, for instance, visible in this image. It's an image of the Toshka Lakes in Egypt. And you see here that, let's say in 2020, we have the lakes are rather small, while in 2021, the water extent of the upper lake is much bigger. You also see that the crop fields, which are these red circles, they have increased in size, so there's some new pivot irrigation in the area. If we look into the land cover products on the bottom, you see that, okay, the change in water extent is captured between 2020 and 2021. But you also see that several of the croplands which you have in the 2020 map were actually mapped wrongly as grassland. So they are now correctly classified in 2021 as cropland. So yeah, we have actually in world cover between 2020 and 2021 both real land cover changes as well as changes due to the improved algorithm, and it means that it cannot be used for change detection. That said, yeah, world cover has been validated and compared with other global land cover maps. So it has been shown that the accuracy of world cover is among the best of the data sets that's available. Also, the spatial detail is the best that's available. So yeah, if you want to read more, please have a look to this paper or this website. In addition to the land cover map, as Vito, we also made some of the input products or input data openly available, like this annual composites of Sentinel-2 data, cloud-free Sentinel-2 composite for the year 2020 and 2021, as well as for Sentinel-1. And yeah, so this is also freely available data, which you can use in your application to build your own application upon. For instance, it was used in this update of this global mangrove watch layer. So there's now a 10-meter global mangrove layer available, and it uses actually these Sentinel-1 and Sentinel-2 composites as input. Okay, this was in a nutshell some of the existing services, existing products that we've been working on. Now we'll just give some more details on some of upcoming global land cover initiatives, because actually, like I said, the Copernicus global land cover at 100 meter, it stopped in 2019. Also, world cover stopped in 2021. However, we're happy that Vito was also recently awarded a new service contract called the Copernicus Global Land Cover and Tropical Forest Mapping and Monitoring Service, or in short, LCFM. And actually, the goal of LCFM is really a continuation and an evolution of these land cover products. So we started about a bit more than a year ago, and yeah, it's implemented by the consortium, which you see here on the bottom. So the goals of LCFM is first to continue the existing 100-meter global land cover. So like I said, stopped in 2019. In LCFM, we also produce annual updates for 2020 till 2026. Secondly, we also improve the spatial resolution towards 10 meter. So it's actually onboarding what we have been doing in world cover in Copernicus. And also, we want to increase even further the temporal resolution. So we want to go from annual products even towards monthly products with an improved accuracy. And finally, what we also want to do in LCFM is extend by creating specific tropical forest products like tree cover density and tree cover presence change at 10-meter resolution. And like I said, there are also going to be some sub-annual products, monthly products, available. So just in a nutshell, this is the different products that LCFM will generate, starting from a set of features at 10 meter, a set of categories at 10 meter resolution, which will be produced at a monthly. So it's a kind of land cover product, but on a monthly basis. Then there will be an annual land cover map for the years 2020 till 2026, both at 10 meter and 100 meter. So it's similar to world cover and a continuation of the 100-meter land cover. And there will also be specific change products. Over the tropics, there will be also some, let's say, specific forest products like tree cover density, which provides a tree cover per pixel at 10-meter resolution for the year 2020, as well as tree cover presence change layers for the years 2021 to 2026. Also, all the training data sets that are used to create these products will be made openly available. So yeah, like I said, we don't have products yet. The plan is, however, to release rather soon the first set of products. So yeah, please keep an eye on the Copernicus land monitoring service website or on the social media to have that to know when these products are released. Finally, I also just want to point you to this project, which is the European Space Agency Sentinel for Land Degradation Neutrality project. It might be also of interest for you. It's actually a project in which contributed also to the development of what we're now currently doing in LCFM. In the European Space Agency project, CEN4LDN, we actually developed methods to monitor land degradation at 10-meter resolution, and this for the years 2008 until 2023. We had a number of case studies, among which Uganda, which you see here in this image. So if you're interested to learn more on what we have actually been doing in that project, please have a look to this website, esa-cen4ldn.org, and there you can find more information on the different products that were generated. So annual land cover maps, annual changes in land productivity, as well as soil organic carbon datasets, and this all at a high spatial resolution, and this for, among others, Uganda. So yeah, to conclude, because I see I'm running a bit over time, I think with land cover monitoring, it really enables informed decision making to protect our planet and its ecosystem. And over the past decade, the last 10 years, thanks to the Copernicus data, we've really seen a shift from more moderate resolution products, static products, using basic machine learning techniques to now higher spatial resolution. So we go to 10-meter and even beyond. We also go to higher temporal resolution. We moved from yearly snapshots, and now we go in LCFM also to monthly products, and eventually also to near real-time monitoring. We created more detailed legends thanks to the richer training data and also more sophisticated machine learning algorithms. And we get more and more user customization, allowing tailored solutions for diverse applications. So we went from land cover mapping and monitoring more towards characterization. So we have now different products that really characterize the single pixels. And we are really in exciting times. Thanks to all this data that's now available, thanks to Copernicus, everyone can make a map. However, creating a good map remains a challenge. And what we also see and what we're currently working on in LCFM is that accurate change detection, it remains key for many users and also decision making. So with this, I want to conclude my talk. Thanks a lot for watching and listening. If you have questions, I'm not sure if we should address them now or if we do it after the second presentation. But of course, you can always reach out to me by email. You see here my contact details on the bottom. So thank you. Not sure if we take the questions now or shall we take them after the second presentation?
Yeah, Ruben, I see that there are a couple of questions, so I think we can take them now and then proceed with the second presentation. Just one thing for the participants, please ask your question in the Q&A section, not in the chat, so it is easier for us to track them. There is actually a question in the chat, and it is about the differences, the advantages, and the applications of Sentinel-1 and 2 compared to Landsat-8 for agriculture.
Well, of course, Landsat is a great source of information. Of course, it's Sentinel-1 and Sentinel-2 data. They're available since, depending on the sensor, 2015, 2016, more or less. Landsat goes back till 1972. With MSS, it becomes it gets really interesting from 1984 with also the thematic mapper. The differences, of course, are the spatial resolution. Yeah, Landsat comes at a 30-meter spatial resolution. The Sentinel data, the Copernicus Sentinel-1 and Sentinel-2 allows monitoring at 10-meter resolution. So yeah, going from 30-meter to 10-meter makes a difference. And secondly, there's also yeah, a big difference in the temporal resolution. Yeah, with Sentinel-1, 2 has a temporal revisit of, like I said, 5-6 days. Landsat, it's about 16 days. So yeah, with the higher temporal resolution, there's a higher chance that you have cloud-free images, but also you can better monitor, let's say, changes in your agricultural practices. So that's the main difference. That said, I think the great added value of Landsat is indeed having this historical time series, which allows to go back until the 80s. And secondly, also, yeah, Landsat has also thermal bands, which can be used for like evapotranspiration transpiration mapping or monitoring, and also for some better cloud screening. So yeah, I hope this answers your question.
And there is also another related question you partially answered already, but Christopher is asking, how can land use and land cover change analysis, how can it be performed, for instance, between 59 and 2024? So you partially answered to that for the time frame. And also he is asking if the existing data sets may be too coarse for a smaller region of interest.
Yeah, well, yeah, of course, like I said, you could go with Landsat back till for sure the 80s, and maybe also the 70s. It gets a bit more tricky if you want to really go work with older data till let's say the 50s or the 60s. Yeah, there is some data available, like there were some spy satellites from the Cold War period that were also made available, like corona imagery. So that can be used. It's mainly panchromatic data. It doesn't have the spectral bands like we had with like with Landsat or Sentinel data. But yeah, it could also be used. But yeah, of course. The more you go back in time, the less data you get. Also, we have the geometric accuracy of the product decreases, the radiometry of the product, the radiometric quality of the products decreases. So yeah, it's a challenge, but it's possible. So, and then the second question I forgot a bit was about
how you can use existing data sets for smaller region of interest.
Yes. Well, for smaller regions of interest, yeah, I think like world cover or the upcoming LCMM 10-meter resolution, I hope this also addresses many of the local requirements. Of course, I know that these are global products. They use global algorithms, and it means that they also have a limited amount of classes. Yeah, it's one of the limitations. But yeah, this I acknowledge that 100 meter is maybe too coarse for several local applications. 10-meter hopefully provide you with the right information. But yeah, I know that maybe it's for certain applications you might need even higher resolution, and you might need also more classes.
Thank you. There is another question from Edward on how to access products of global land cover mapping and training data. So this video recording and this presentation will be shared, so that there were links, but if you want to reiterate where they can find the data and the trainings material.
Yes, I think, well, the Copernicus products, like the global land cover and also the upcoming LCFM products, they will be available through the Copernicus data access points. They will be, like LCFM will be hosted on the Copernicus data space ecosystem. We have like the 100-meter land cover is now also available on this land.copernicus.eu, but it's also being transferred to the Copernicus data space ecosystem. And world cover is available on a specific project website. Several of these products are also ingested in Google Earth Engine, so people familiar with Google Earth Engine can directly use it there. You could also download it from several of the products from Zenodo. Some of the products are on Amazon Web Service. So yeah, they're a bit scattered around. There are various ways of accessing them. That's also because it's open data. So yeah, it can be users put it somewhere on different platforms, different repositories. So yeah, but please have a look to either the project websites or the Copernicus Land Copernicus website to give all the access points.
There is another question from Daniel on how the image processing work from raw satellite data to the imageries that we use for land cover monitoring. So tomorrow we have a presentation on the Copernicus data space ecosystem, how we produce the images, but if you want to elaborate on that.
Yes, well, indeed, what we typically do is we start with the raw data. For Sentinel-2, this is actually the level 2A data which we use, which is the surface reflectance. So it's atmospherically corrected data. For Sentinel-1, we use the radiometrically terrain corrected backscatter, so-called gamma naught. So we use this raw data. Then we do some pre-processing. We do some for the SAR data. We do some speckled filtering for the L2A data. So the Sentinel-2 data, we do cloud masking, and then actually we're gonna create features, which we use then in our classification. We mainly make annual statistics. So we take the full time series of, for instance, of Sentinel-2 data, and we see, for instance, what was the maximum for a certain band, was the minimum over the year, and what was also the median. And these are then also called features, which you use then to train a model. So we have our training data. So we know points on the Earth where we know, okay, this is a cropland, this is a forest. For these, we extract these features, we train a machine learning model, and then we run this machine learning model. We do inference over the full globe. So yeah, this is typically more or less the workflow. Of course, it's a lot of data crunching, and indeed we rely here on the Copernicus data space ecosystem, on the cloud environment to run all this, because yeah, we're actually using petabytes of data as input.
Thank you. Edward is asking, which bands do you consider to get information on land surface temperature?
Land surface temperature, actually, in the maps that I showed you before, we don't actually use land surface temperature like Sentinel data. At least Sentinel-1, Sentinel-2, it doesn't have a land surface temperature band. Yeah, like I said, there are some proxies, like the shortwave infrared also is sensitive to the temperature of the Earth's surface. That's, for instance, what was visible in this composite where you saw the forest fire. Actually, these bright spots, they were very hot spots because they had a high shortwave infrared reflectance. But yeah, we don't use land surface temperature in the product that I showed you earlier. We do. Yeah, however, if you want to use it, you can use it either from Landsat, or there are also more moderate resolution sensors. I know there are also upcoming Copernicus sensors that will have thermal bands on board, like the LSTM sensor. So yeah, it's not there yet, but yeah, it will come in future as part of Copernicus. I'm sorry, Sonia, you're on mute.
Thank you. So Mafuza Maya is asking if you can map Gallia-Rajan in classification using combining Sentinel-1 and 2.
I mean, gully erosion. Yeah, that's a good question. To be honest, I'm no expert on gully erosion. I think it should be possible to help, at least in the classification with Sentinel-1 data. Yeah, the topography is somehow a bit also visible in the Sentinel-1 backscatter. So yeah, I think it should be possible, but like I said, I'm no expert on the thematic. So yeah, I don't dare to say much.
So there are many more questions for you, but I think that maybe we can proceed with the second presentation, and then we can come back to the questions if we have more time. So thank you so much, Ruben, for your presentation and for all your answers. And
Thank
now,
you.
thank you. And now we have with us Koen de Vos. He is remote sensing scientist at Vito Remote Sensing. I leave you the floor for your presentation. Thank you.
Thank you, Sonia, for inviting me. So yes, my name is Koen de Vos. I'm a remote sensing scientist in the agricultural team. So that means that our work is mainly focusing on agricultural applications. And I will be showcasing today what products and services that we created for agriculture and food security. I will share my screen. Okay, I think you should be able to see it. So today I will give an overview, not just on what products and services that we created, to show you how good we are, but also to spark your interest in what is feasible using Copernicus data, different inputs, mainly the sentinels that Ruben also explained earlier, but also different ones. I included in every slide where I show a product, which Copernicus product we used, but I can come back to this later as well. So typically, when you work in agriculture, it's a bit like the question that was raised earlier with between Landsat and Sentinel. The first thing that you think of is, okay, which data do we use for this application? And depending on the scale, depending on the thing that you actually want to map out, you use a different type of data. This can be satellite imagery, where mainly we use Copernicus, but if you go to very small scales, this can also be using drones. This is also something that we do, but I will not be discussing this today. So I want to first start at the very large scale, where we use drought monitoring. This is a service that we provided for the Food and Agriculture Organization, where we co-developed and made the ASIS system, the Agricultural Stress Index system, operational, where we provide this information at near real time, information about what the current agricultural stress is around the world, to highlight areas where effective droughts are impacting agriculture. This also leads to very impactful and interesting results, where you can actually follow a drought happening. In this case, you can see the red indicating severe drought or at least strong impacts of droughts on vegetation happening within 2021, 2022. This information can also be used in different contexts. For example, together with ITC, we developed a system that builds further on these drought impacts to also get an idea of how insurance should be dealing with this. In the left, for example, you can see an image for Somalia, where the red areas are indicating where effectively the impacts of drought have been worse, and that based on a certain reimbursement scheme, it would be beneficial for the farmers to be reimbursed there as well. Now, following up on these droughts, we have been included in a large Horizon Europe project called Centaur, where you can see all the partners here on the left, where we are producing for specific countries. In this case, we are working on Somalia, Mali, and Mozambique, where we are producing similar maps where we are showing agricultural drought risks. We are doing this at near real time. So that means that we are also providing information for specific regions. Here on the right, you can see one for 2022, again for Somalia. And here we make a clear distinction between grasslands and croplands to also discern between the impacts on livestock at one hand and croplands on the other hand. Within this project, you can also see that we are working on 1 kilometer resolution, so that we are providing this information not just at the regional scales, but also up to, I would say, higher, but it's not high resolution 1 kilometer, but even within a region that you can really highlight which areas are more affected by these droughts. Within the same project, we are also using this Earth observation data and this knowledge on droughts on agriculture into some downstream modeling applications. For example, we have developed together with ECMWF, who are responsible for meteorological forecasting. We have developed a system that is able to forecast the impacts of droughts on agriculture up to 10 days, 1 month, and 3 months in advance. It more or less looks like the figure that you see moving on your screen, where we have delineated areas in terms of NDVI. So in this case, we use the Copernicus Global Land Service NDVI, which we indicate these are safe zones and these are highly impacted zones, and we can actively forecast what the level will be in a couple of months. For this forecast, we have built an entire model that is able to do this, where we use multiple Copernicus inputs like the soil water index, but also the elevation. Within the same project, it's quite an ambitious project. We are also taking it a step further to actual food security and the impact on the people itself. Together with other partners, we have developed a model that is able to use all of this information that is coming directly from the Copernicus data to predict again in advance whether there will be some conflicts in specific regions, or whether there will be some human displacements. So we are indeed taking it a step further to food security, not just agriculture. But this shows that even though that the satellite data might have can actually have a lot of implications also for downstream modeling cases, where you can actually use it for a lot more than you might think. An example that we're also supporting is the Mars crop monitoring in Europe, where we are providing Earth observation data to the European Commission, actually since quite a long time already, where we are providing all the required inputs for them to run their own crop yield modeling system, so that they can also provide crop monitoring bulletins and provide information to high-level governments, but also policy workers that require this information to get timely activations. So how do we do this mostly? We base ourselves very strongly, same as Ruben did, on Sentinel-1 and Sentinel-2. One thing that we are quite proud of and that we actually use quite a lot is something that we developed because it was already mentioned that Sentinel-2 has the disadvantage that it has a lot of cloud obscurance, so that you don't always have a signal or a usable image available. So something that we developed using also some AI frameworks is how to use Sentinel-1, so the radar imagery that you have available, to mimic some sort of how the temporal profile of your Sentinel-2, or in this case, the FAPAR, would look like. And this is something that we use, and actually these time series are, in terms of agriculture, very important, because they they really tell us what kind of crop is on there, when the growing season is starting. So for us, that is really, really important to understand and to use in our products as well. And finally, you can get some more smoothed imagery. Here on the right, you can see, for example, how the NDVI has been changing for an entire year. And this already shows very clearly that using this information, using this derived time series, you can actually really get the separate parcels out of there and understand how the different parcels are behaving over time. And this we actually do use, for example, in some recent products at the European scale, where we are producing crop type maps for the entirety of Europe at 10-meter resolution. You can see some of the crops listed here as well, and on the right in the top, you can see which time series we used and also some information that we can get from this. If you can see that if it's the value is high, that we are in the season. If there are two such high periods within the year, then we can detect that there are two seasons. You can also detect the low values to be bare soil or fallow periods, but also based on some techniques that we can use, we can identify when the harvests are there. So it's actually a lot that we can do with this time series, and it's also a lot that we do with this time series. One very interesting project that we have is the World Cereal Project. I think the name quite says it all. It's a product where we produce maps of cereals. Some of the main products are in the top, but also crop-specific maps of maize, and I think wheat at the moment are available at 10-meter resolution. It's World Cereal. It very strongly links to the World Cover product that Ruben mentioned before, because you can view it in the same suite, that it's at a global scale at this 10-meter resolution. That we use very strongly Sentinel data for from the European Space Agency on. This is also something that we use the algorithm behind this for the Copernicus for GeoGlam service, where countries can request a specified crop type map, where we will be creating a crop type map for that specific country in a very specific year. And then we can also go to more specific crops that are very tailored for your own country, that might not be the more important or interesting at the global scale. But we also provide some services for farmers themselves, and we try to bring Earth observation data, the Copernicus Sentinel data, for example, to the farmers themselves. In Belgium, in Flanders, we have a platform that we are governing that's called Watch It Grow, where the farmers can actually see how their fields are doing. And if they see that in the greenest, for example, that there are some browner spots in the field, that they know that these are also the places where they can take subsequent actions on, improve fertilization or change irrigation patterns, for example. Yeah, but it's also sometimes we move away from agriculture itself more to food security. In this case, we collaborated with IGAT to develop desert locust suitability mapping to be integrated in their East Africa Hazards Watch platform. As you can see here on the left, this also leads to interesting information that we can use to identify where the locusts are likely to be at the moment, and by combining this with information on agriculture, or even what we expect agriculture to be based on the time series, we can make estimates or make assessments of how the damage by the desert locust was on cropland. In this case, here you can see something that we did for Ethiopia, where you can really see that that the central Ethiopian region and Amhara and Tigray in the north have been affected more by locusts in 2020. But also over time, we can make very important estimates and provide important information to local services and local authorities. Here, an example for the Sanaag region in Somalia, where you can clearly see that the suitability or the likeliness that desert hoppers, so the very early stages are there, are also really bound by how the vegetation changes. So this is also information that we can use and we can derive from the Copernicus data to improve, for example, the control of desert locusts in the region. We can also use this to assess biomass productivity for pastoral areas, where we look to what the builder biomass would be, again linking back to the livestock areas, where you can really identify areas where the biomass is not growing as it should be, and where we thus expect issues also for livestock to occur. And then some more recent projects that are also in their way. In this case, this is from the Scalec data project, also at the European scale, where we are trying to improve yield monitoring by integrating Earth observation and field data. So really coming from the machinery themselves, which is then fed into our modeling systems to improve basically the yield monitoring, the yield understanding how it all works, so that using these satellites we can better identify where things are going wrong and when things are going wrong. Also, it's again linking back to my first slide. Within this project, we try to bridge the satellite and the drone imagery, which in the agricultural sector have been used both, and do not really have found their way together, while we strongly believe that each of them have their own benefits and can work very complementary together. And then finally, I want to conclude with a platform that was developed by some colleagues of ours, where we try to bring together some meteorological information, but also some dedicated crop type and crop information in the ClimTag platform. And maybe I can briefly show you how it looks like. So here, you can see how it looks like for Ghana, for example. In this case, we are looking to the onset of the season when it occurs based on Earth observation data, and you can actually have a look to the different regions. It's a platform, so you can really explore it a bit, see how it looks like. You can see how it changes over time, and something that is very interesting as well in terms of climate resilience is that you can also look to what climate projections will say, for example, and how this will affect under different climate scenarios, how the seasons will change, for example. In this case, you can see that the crop calendar for this very specific region in Ghana, we do expect based on climate projections that indeed the onset of the season will become later in the year based on this. And there's a lot of things to be found in this platform. I won't be showing all of them, but you also have the meteorological ones, precipitation, temperature, more information on land. The land cover information is also available here. So it's a very useful tool for farmers, but also policymakers alike. I think that's all I wanted to say. So thank you, and I'm really looking forward to the questions.
Thank you, Colin. Indeed, very interesting presentation. So we have a couple of questions already. One from Edward. So you talked about crop types and length of seasons. He was wondering if you're also able to quantify statistics on the area under various crop types.
I am not sure whether I fully understand the question. I think it's possible that there's two questions, so I'll answer both of them. So using these maps of crop type, we can derive regional statistics of different crop types within a certain area. That's very much possible, and that's also where a lot of these data are being used for at regional levels. Some countries are using this to validate the regional statistics as well, agricultural statistics, or to complement them. Another possibility where the question might be heading is to identify different crop types in one field. And we are currently only working with single cropping, so not intercropping, also because we're bound to this 10-meter resolution. So if there are multiple crops within 10-meter resolution, then it's not possible at the moment to discern.
Thank you. There is another question from Julius Kimani about the locus mapping you showed. Is there a way someone can be trained to come up with such visualizations using satellite images?
Well, I think the model that we currently developed, we have been developing this with EGAT, and it's supposed to be launched in their platforms, so it should be available as is. And for the rest, I think it's also trying to see what's available in scientific literature. I think we can also communicate after. But the main thing there is that you try to understand how the locust or any other pest, can be any animal. Some colleagues of ours are also doing this for just habitat mapping in general, not just for locust. And there it's really to understand first from an ecological point of view what the animal or the pest in that case, what its living conditions are, and then try to see how that relates to the actual Earth observation. And for this, for locust, we rely heavily on a lot of in situ data that has been collected by the Food and Agriculture Organization as well, where they do a lot of ground control for locust, and that helps us to understand where they are and to which imagery or responses from these satellites that it relates.
There is a request to explain further how biomass productivity can be predicted.
Well, I have to be honest there. I'm not really the biomass productivity expert from our team, but I think that how they do it is that they again look to these curves, this time series, and that they see how that develops, and based on I think it's some sort of algorithm that they use on those, that they can discern the biomass productivity from this. But I know that there are other possibilities as well, that you integrate this into more advanced models, for example, where you also try to link what you see with your satellites with the output of models, and then use this to understand what it might be.
Yeah. Edward Yuma, he is asking to what extent can NDVI time series data on crop types be used to forecast and predict yields before harvesting?
It's a good question, and it's also something that we are currently thinking of, because it's also not a one-on-one relationship. It's not NDVI is a measure of greenness, and greenness is not always directly related to yield. But there are indeed some strong linkages. If there is, for example, a drought or any other disaster that occurs, then you can see this reflected in your NDVI signal, and there will also be an impact on yields. But it's not a one-on-one relationship. And with the forecasting that we are doing in the Centaur model, we are trying to understand how this works, and we are currently trying to identify this for droughts, but that's not the only thing that affects yields. There's a lot of more factors that are governing this, and I think up on this point we're not there yet. There are a lot of possibilities as well, again linking it to crop growth models, but so it's not a one-on-one relationship, and it's not feasible at the moment.
Thank you. And one last question from Peter Hongo. Is it possible to generate crop heights data from the Sentinel images?
I think there's a lot possible. We are not really working on the crop heights themselves. But again, when you look to the standing biomass, I think it's somewhere related there. Also, when you're talking about heights, I think Sentinel-1 comes more into play. Again, also when you look to the time series of NVI or any other band of Sentinel-1 and 2, there are very likely things that you can get out of there, but the very core of all of these applications is that you have in situ data that you can use to understand how your actual real world applications, in this case, how your crop height relates to different values of the bands of Sentinel-1 and Sentinel-2.
Thank you. So I don't see other questions for you. So maybe we can go back if Ruben is still available. You can stay with us, Cohen, of course, for other questions that might have come. Thank you, Ruben. So there were other questions for you. For example, where can we access the Sentinel-2 harmonized data? Valentin is asking, he knows that we can access them from Google Earth Engine, but is there another source?
Sorry, I don't really understand with the harmonized data. I know there is in the on Google Earth Engine, there's indeed a Sentinel-2 harmonized collection because there were some changes throughout the different processing baselines of Sentinel-2, and I think the harmonized collection tries to harmonize this processing baseline so it can be used for further analysis. But there is also some, let's say, Landsat Sentinel-2 harmonized data, which is also available. So I'm not sure which harmonization was meant here, but yeah, I think either on Google Earth Engine you find a harmonized collection of Sentinel-2, this harmonized Sentinel-2 Landsat data. I think some of it is also Google Earth Engine. You can download it also from NASA. Yeah.
Thank you. And there was another question from Valentin about the ESA CCI global land cover. Spanning from 1992 to 2019 with 300-meter resolution. He would like to know if there is a plan to continue the project. If you know.
Yeah, well, actually, the ESA CCI land cover, it has been continued in the Copernicus Climate Change Service. So it's C3S. The C3S land cover is actually produced by the same team as the CCI land cover, so it's actually continued there. It comes at 300-meter resolution indeed.
Nathaniel Piri would like to have a bit of an explanation on what you described for the data sets available. So he's saying how come that the satellites, images from satellites are available every 5 to 6 days, but then we have data for the products only for 2019 or 2020. So maybe a bit the difference between the satellite images and the data sets available in the products.
Yeah. So indeed, the data that I showed so far in my presentation were annual products. So actually what we typically use is a full year of time series of the data. We create, like I said in one of the previous questions, we create annual features out of it, being percentiles, summary statistics, so the maximum, the median, the minimum over a year for different bands, for different indices. So yeah, actually from the full stack of 5-day images, we actually condense that or reduce that into a set of meaningful features, which we use then to create our annual products. I hope this answers your question.
Thank you. There is another question from Valentin as well. Which metrics do you use to assess the accuracy of the land cover products you create? I heard that kappa is no longer suitable.
Yeah, I think indeed we use mainly overall accuracy, producer accuracy, user accuracy, or sensitivity, specificity. We use F1 score. Yeah, I think they're all related. So we use both, let's say, overall figures as well as per class accuracies. We do this at a global scale, but we also look at continental scale actually, yeah, because it's also important to see these statistics at a continental or even biome scale, because continental or global figures don't say it all. It doesn't give an idea of the local spatial accuracy you get.
Yeah. Adiowa would like to know if we can combine data from Landsat and from the Sentinel. So, for example, using Landsat from previous years, so before 2015, and then use Sentinel data for recent years.
Yes, indeed, that's possible. I think we also did it already at Vito, where we used Landsat data to create land cover products until 2015, and then we used more recent data from Sentinels to create more detailed products. So yeah, there are some differences in spatial resolution, differences in temporal resolution, differences also in the spectral bands that are used. But yeah, there's a lot of overlap between Sentinel-2 and Landsat data. So actually, if you have good training data and you need to let's say calculate different features, you need to train separate models for the Sentinel-1, Sentinel-2 data, Sentinel-2 and Landsat data, unless you have one of these harmonized data collections. But yeah, it can be used, and yeah, there's a lot of overlap between them.
Thank you. There is another question from Tom Kemboy. For the pilot project on land degradation neutrality, is the data available in trends.earth, which is the default tools for countries to report on their LND targets?
Yes, yeah, that's a good question. The data is there actually currently not available in Trends.Earth. We're currently discussing together with the European Space Agency to make also the tools to create or calculate this data sets openly available. Actually, the workflows have been implemented in OpenEO, which is actually a kind of European alternative to Google Earth Engine. It's also part of the Copernicus data space ecosystem, so it might come in tomorrow's presentations. And we can actually, OpenEO is an API, so you can link this API together to Trends.Earth. So yeah, it would be possible, but it's not there yet. Yeah.
Okay, and there is a follow-up question. How did your team validate the maps for Uganda?
Yes, as part of the consortium, we also had a validation partner, being Wageningen University. We do, for the validation of the maps, we collaborated together with Busitema University from Uganda, and so we had also some local knowledge for the validation.
There is another question, I think it's more for Corinne. Is it possible to generate height of trees using Sentinel-1 and 2?
I think maybe Ruben can follow up, but I think it's very likely, yes.
Yeah, well, actually, you have a number of available tree height products already available. There's a product from the University of Maryland. There's a product from ETH Zurich, from Nico Lang. So the first one is from Peter Potapov. There are also some other products upcoming. So typically, what these products use, they use training data from either the JEDI sensor, which was on board the International Space Station, or the ISAT data, which is another satellite. So these are kind of LiDAR satellites, which take point samples of tree height, and then actually what's being used is kind of they train a model between these tree height points and also the Sentinel spectral features, and then this is run or extrapolated over space. So yeah, these products are already available, both the 10-meter and 30-meter resolution. So product from Maryland, from Peter Potapov, and the product from Nico Lang.
Thank you. There is another question from Iona about the assessment of biomass productivity prediction. I think Cohen already answered. I don't know if Ruben, you have anything to add on the topic.
Not really.
No. Okay. So I think we've answered all the questions. If there is a raised hand. So Tony, you should be able to unmute yourself.
Thank you. I had raised, thank you first for that presentation. I had raised the question of upsampling, and maybe just to clarify, I think it's also a follow-up looking at the comparative land use land cover from the two providers, that is Sentinel and Landsat. And the idea is, do you have any experiences of upsampling from the 30 meter, assuming you have maybe a 1990 Landsat image, and you want to have similar spatial resolution for you to be able to make the land cover change analysis from maybe the 1990s to period 2020 or something of sort? Any experiences that can be shared on this? Thank you.
Yeah. Well, of course, going from 30 meter to 10 meter, yeah, it's actually, you increase the spatial resolution with 9, factor of 9. Yeah, what we typically do when we upsample, yeah, either you use some, let's say, kind of pine sharpening techniques, or you use some, there's now also some new AI techniques which can do super resolution, which we also use. But you can also use some let's say continuous interpolation, like B cubic, B linear. So it depends a bit on the application, what's most suited. Of course, these are just, yeah, let's say data. Yeah, you create additional data. It's yeah, it all depends on the application. So yeah, I'm not sure if that answers your question.
Yeah, thank you. Thank you for that. Generally looking at land use land cover change, maybe with particular interest with something to do with maybe like forest. So maybe it's the super resolution, I think, small experiences with it, but in terms of validation, maybe what parameters would you probably advise on this? Thank you.
Yeah, well, to be honest, I'm no expert on that, so I also should look a bit in literature. What's now the current state of the art for super resolution between Sentinel-2 and Landsat? But yeah, I know there are quite some, let's say, techniques. So yeah, sorry, I don't think I can help you with this particular question. What I do know, however, might be of interest to you is I'm also part of a project called Evoland, and in Evoland we have developed a super resolution algorithm together with our partner SSBO. And actually, what this does is it improves the spatial resolution from Sentinel-2 to 5 meter resolution even, and then that's so you might also have a look into that algorithm. So Google Evoland and then the super resolution, and you will also find the page. So yeah, but sorry, I cannot help you further with your question.
Okay, thank you for that.
Thank you, Tony, and thank you, Ruben. There is another question from Yuma Makandi. Do you have or are you aware of any training program in Tanzania on the use of remote sensing for food security, especially in crop yield prediction?
Not directly for Tanzania. I know that there is an Africa-wide training program rolled out by the European Space Agency called EO Africa, where a lot of people can just enroll and learn more on how to integrate also Copernicus information into their work streams. So that's one. I know that we also have been doing some country level mapping in Kenya and are currently performing a feasibility study for Mozambique. So I'm yeah, very likely it's also possible in Tanzania. And we can follow up later. Maybe you can contact us as well.
Thank you. Yeah, there is another question on, again, index that are used for biomass computation, but I think...
I'm not really the expert, but you can contact me and I can put you in contact with the right persons internally.
Perfect, indeed, thank you. We will share your presentation with the contact. I don't see any other questions, so Stefan, do you want to intervene maybe?
No, I just want to really thank Koen and Ruben for these presentations. I have learned a lot of things, so I'm pretty confident that our audience has also learned a lot. My key takeaway is, there's been an amazing progress in the development of fit-for-purpose operational products in all these areas. B, Copernicus is really at the forefront worldwide when it comes to the variety of the products. 3, what makes a big difference with most of the other available products is they are operational. Operational means there's a guaranteed continuity and means they are validated and independently quality controlled, which makes a world of difference. So, and they're, well, that we said already yesterday, it's free and open data, and it's not data that we just develop for the use of Europeans by Europeans. It is something that we are collaborating with African partners for in situ, for defining the needs, et cetera, et cetera. So I think we were very lucky to have both of you presenting, top-notch experts, the ones that are actually developing the products. And I hope that our listeners will go away with lots of ideas, and what really matters, they will start using those products. Once again, as I said yesterday, the plan, I understand, is to it's land cover, so to uncover, to reveal the first light on the global land cover and tropical forest mapping and monitoring service at the mid-May at the General Assembly of the Copernicus Land Monitoring Service. So indeed, as said by our colleagues from VITO, stay tuned on the Copernicus Land portal website and on their social media. There will be announcements, and I hope that you will appreciate the availability of this groundbreaking product that has many applications, obviously, on the African continent and beyond. So again, thank you very much to VITO colleagues. Thank you very much for RCRMD for taking the initiative of requesting that we organize this series of webinars. And thank you to my colleagues of the EU Space Support Office and to Sonia in particular for organizing and moderating. And see you tomorrow for the last session of this series of webinar. Thanks again, Koen and Ruben. And looking forward to having even a copy of the presentations, because I want to share them with other colleagues, because there's a lot of really informative material and links. So once again, thank you.
Indeed, thank you, Koen and Ruben. Thank you to the participants. And we meet tomorrow again at 10 Central European time or 11 Eastern Africa time for the presentation on the Copernicus data space ecosystem, the Copernicus browser, and a demonstration on how to use the data.
Thank you so much. See you tomorrow.
See you tomorrow, Grace.
See you tomorrow.